Fifth will be Sujata Koirala. Sujata Koirala. Some of the volunteers, please, if she is here, can you please search for Sujata Koirala? Okay. And the sixth one, there will be two students presenting. So, without further ado, I would like to hand over the mic to session chair.
Thank you, Dr. Rajit Oza. That was a splendid introduction for us. Good afternoon, ladies and gentlemen. सबैलाई लन्च पछिको सेसनमा फेरि पुनः स्वागत गर्दछु. We are here gathered after the lunch, so you must all be feeling full stuck and a little sleepy. But believe me that we have got a wonderful constellation of panelists here who will be presenting their experiences, very rich experiences, and they'll keep you awake to feed your appetite of your knowledge. All the stomachs might be full. So without further thinking on this, I'd like to first invite Professor Dong Woo Jong, the professor at University, to present his paper. Yes, please. Sorry. Before you start, I will just like that because we've got 5 papers here, and we also have 2 students presenting. So it's like about we've got 2 hours time. So in order to manage the time, that everybody has got a reasonable time to present their papers. So let's limit that. We will each be presenting about 12 minutes. So that by 10 minutes, I'll just give a thing and you can please start winding up after 10 minutes. So I request all presenters to keep it to your time of about 12 minutes. And after that, we can have question and answers. And again, if there are no questions and answers, we can also discuss among ourselves. Nice. Thank you, Professor. You should start.
Thank you. Hello everyone, I'm Dong Woo-jang from Incheon National University, South Korea. My topic is the improvement planning of the water resources and water supply system in Benin municipality. Actually, I'm engaged in Society of the Smart Water Grid in South Korea, and our group are preparing some KOICA aid project for Benin municipality. We wanted to install some advanced infrastructure for water supply system in Benin, and we wanted to make a good infrastructure and good management system for Benin municipality area, and we wanted to expand this project to other Nepal's small municipality. So today I'd like to introduce about our research project and our plan for KOICA project. This is my content. So first I'd like to introduce our Benin municipality and our purpose about smart water grid. And second, I wanted to talking about the Beijing research and the improvement plan of the water supply system in Benin municipality. The smart water grid concept is the combined with a conventional water supply system with information communication technology. So this is some conventional water supply system. So we take the water from intake facility, and that water is going to water treatment plant, and with supplied water with stable conditions. So we combine the ICT, so it is possible to water source and water energy consumption and cost reduction with smart water grid. So in smart water grid project systems, we manage the whole system, and we take the data and some device for measuring. So all is included in smart water grid. So in Korea, our some conventional system to water supply is the some single pipeline, but actually this system is very weakness for disaster and some accident. So in smart water grid project, we wanted to check all data. So in water resources, we check the intake facilities data and water supply discharge and water treatment water quality. So based on data, we can make some plan for appropriate water supply system and treatment facilities management rules. So in smart water grid, we wanted to focusing on data. So the data can take from the water resources points, and we want also the base demand for drinking water or some commercial water and industrial water. Their own data is important for checking the water balance for water supply and water demand. And so in smart water grid, we want to make some integrated water supply system. So from intake facility, like there are various water resources, and this water will going to a water treatment plant. So in water treatment plant, we wanted to check the water quality monitoring. So from the water resources to water treatment plant, and it connected to water distribution system. So finally, the peoples and residents can take their water with some clean water, and this is based on water quality monitoring and water supply monitoring. This is some introduction of the Beni municipality. So Beni is located in Gandaki province, and their population is 33,000 people living in Beni city. And actually, the Beni municipality's the water supply system is only for number 6 and 7 and 8 district in Beni municipality. So you can see there are villages in Beni. So around 6,000 people receive the tap water. So we wanted to make the more improved system in Beni municipality with our smart water grid project. And actually, the Beni municipality is one of the small town with a small town water supply and sanitation project. So the Beni is the number 6 municipality in STWSSP project. So when we start our project, and when we make some plan for a water supply system with some advanced methodology, so we wanted to check the water resources and water supply systems status. So when we check the precipitation data for near the Beni municipality, we can see the annual precipitation is higher than 1,500 millimeter. That is some abundant water comparing with the other country. And also, when we check during 30 years average precipitation, every month there almost precipitation is concentration on only summer season. So this is some problem for drought season. They're taking the water. Sometimes it's problem for they save the water. And based on precipitation and temperature data, I analyzed for a drought index for Beni municipality. So I used the RDI and SPI, the index for drought. And if this drought value is lower than -2, that means it's the extremely dry condition. So for Beni municipality is the only for 1991. That years is only for lower than -2. So after that season is all for abundant water, and there is no problem for heavy drought. And about water supply system of the Beni, Beni have the 3 intake facility. So there is 3 intake facility, and they use the water from a spring and valley water. So during some summer season and there is no drought, they can use the spring water. But in drought season, sometimes the spring water is shortage, so they need to use the water from the valley or river. And their water supply system consists of some gravity system. So there is no need for electricity for water supply. And I received some data from some engineering company from last conference. So I received some 3 districts for water supply network in Beni municipality. So this is the district of the water supply system. And based on this network file are combined together to make a one file. So there is water treatment plant and located here and supply the water from here to whole of the Beni Bazaar and Beni water supply area. So you can see some result for hydraulics, so like some velocity in a pipe and pressure at its junction in water supply system of the Beni. And for the water supply system in Beni, they have planned for increase their water discharge. So if the Beni municipality wanted to expand their water supply system, and if they wanted to supply more water to the people, they need to make some good system and advance some water quality treatment plant and some required for infrastructure. And when we make some design for supply the water, we need to considering about their water supply system conditions. So first is the coefficient for roughness. So now the Beni municipality water supply system is ideal condition. Like their pipeline is the maybe plastic or PVC or steel, but their setting is the 150. The 150 means is the ideal condition for roughness. So there is no friction in pipeline, so it is very smooth condition, and it is good for water supply systems. And when we use their checking the hydraulic pressure, in general cities, the regulation of the hydraulic pressure in the pipeline is the 50 meter. The static pressure is the higher than 50 meter. But when I received their original file for water supply system in Beni, their hydraulic pressure is lower than 50 meter. So if we wanted to more water to supply to the Beni municipality, it is important thing is that we have to make their pressure to increase until 50 meter. So based on this, for making to manage it to their hydraulic pressure in pipeline system, in Beni is required more pump and make a more valve infrastructure. So I installed the pump and valve in water supply system. So with the ideal condition for roughness and make a hydraulic pressure higher than 50 meter, we required more pumps and valve, and it is calculated by this, and it requires some electricity with this value. So based on this research, I improved their hydraulic pressure higher than 50 meters comparing with some current condition, like that. And other condition is the change the roughness coefficient as 120. So that means is some more of old pipeline condition. So if the time goes by in the future condition, if the pipe is more deteriorated, we need change some coefficient of the roughness. So when we use the C value with the 120, and when we make some hydraulic pressure with 50 meters, that times we need more power electricity for managing of the water supply system in Beni. So when this condition is, we can see the in original condition of the pipe diameter and pipe length, we can make it the higher than higher the pressure condition in every junction and for in hydraulics analysis. And next is some improvement plan of the water supply system in Beni. So our group visited 2 times in Beni municipality. So we checked the intake facility. So when we checked the intake facility, we saw the abundant water in intake facility. The intake facility force is the structure for taking the water to supply to the water treatment plant. So it is the abundant of the water. But if we in drought season, sometimes there is no water from spring. So when we take some data and data management, we required from data. So we wanted to install some device for checking the water depth. So if the abundant condition in intake facility, we can check that there are some data for their water resources and water discharge, so we can control of the and we can make some plan for more good system for water resources part. So this is some installation example in Korea in Smart World project. And about the transmission line, transmission line means from intake facility to a water treatment plant. So we also have some plan for transmission line with a dual pipeline, and we can make some design for required location for pipeline. And this is some water treatment plant, and we wanted to install some chlorine disinfection facility and some smart water system like some database server and some software for managing the monitoring data, and some rainwater harvesting infrastructure also we wanted to install in Benin municipality. So we make some plan for during 3 years, some short-term planning. So this year will be we are some preparation process, and from this year and until 2022, we make some basic design, some application, and some operation and improvement of the our installed infrastructure with the KOICA project. So this is consists of some basic planning and facility improvement and water resources development and IoT and smart metering and application of the smart water grid. So application of the smart water grid means include about hardware and software combination. So based on this, the water supply system manager and operator can use their facility more improve the system, and the people can receive the more clean water with a stable condition. So the conclusion is like this. So in our study, we are really focusing on a water supply system with ICT. So when we finished our KOICA project, the Benin municipality will be get more advanced infrastructure. And based on this, we wanted to expand our technology and our experience to the other municipalities. So we wanted to more good collaboration process with Nepal and Korea. Thank you very much.
Thank you, Professor Jong, for the very excellent presentation. I think what we will do is we'll take the questions in the end, so it will be more streamlined. So rather than going one by one, so that's how we'll move forward. Now I'd like to request Professor Yon Sek Hong. He's also from Korea, and he's going to present a smart metering applications in Korea, and we've got much to learn from this maybe also. Thank you for the very good presentation.
Good afternoon, everybody. My name is Yoon Sik Hong, professor of International University. My major concern is ICT, how to incorporate ICT technology into the smart water management systems, especially how to can get water consumption at every household in real time. This is the smart metering. So I'd like to talk about smart metering applications in Korea. So nowadays the technologies are improved. So sometimes Internet of Things networks are established, and the wireless network technology covers long area with a longer battery life like that, and some kinds of AMI devices with economic price and reasonable network fees. So we can apply this technology into the smart water management. So what is the smart metering? Smart metering equals to smart meter with the AMI. AMI means something like the data communication over the wireless network. So nowadays we can build some water management hardware. So they are focused on the how to make or how to install hardware systems for supplying waters. But paradigm is shifted to the software-based water management. So to do this, we can build the large set of water data and integrated systems, and we analyze these data to analyze how to demand, how to supply. So these are the smart meterings. So what is the key elements in smart meterings? So we need smart water grid systems, just IoT, Internet of Things, smart devices, and smart services for integrated big data and some smart solutions with the application of artificial intelligence. So in this time, we have applied some ICT technology for the water management, because devices ready to stable, battery lifetimes are increased, and network is very, very stably operated, and we need some reliability of data, because we needed to smart water management. In that case, we needed to rely on data reliabilities. So in this presentation, I would like to talk about how to measure the water consumption at every household in real time. So many cases, some operator visits households to check the water consumption per every month, but sometimes they did not meet the households because sometimes they are not at home. But sometimes cars are parked on the water meters, so they cannot measure some water consumptions. How to solve them? So when we are trying to measure the water meters at real time, we needed three steps. So metering and the remote transmission and real-time monitoring. These are integrated single systems. So we needed to make some networks and some software systems and some IoT devices like that. And we needed to make some communication infrastructures. But I don't like to talk about these communication technology in more detail. So there are many kinds of smart metering plans for international standardizations. So in Korea, there are some kinds of water meters like that, but in Korea, typically use the kinds of mechanical water meters like impeller types. So how to operate impeller types? There are some propellers. So how many times propellers are turned? So they can count the number of rotations and then measure estimate the water flows. But for the smart metering, we needed more advanced kinds of water meters. Okay, in the smart water meters, they can display some various kinds of parameters like that. So this is a typical implementation. And I'd like to talk about the smart metering. Smart metering in Korea. So the city is the Gochang. Gochang is a small city located in southwest. Population is 60,000 and household is 28,000. So this population is similar to some kinds of Nepal small cities. This city tries to make some smart meterings. What have the problems? They try to implementation these kinds of smart metering techniques. Their goal is like that. Water meter is replaced with a new one. So goal is 24,000, but 23,000 is replaced. So the ratio is 89% like that. So to do this, they have a 9 months project. So what is the most important thing is they are trying to visit and make a meeting with the consumers to hear their needs. So usual data, and they can build the map of the city, and they plan the rock plan. And the most important thing is the coordinator. Coordinator means the collection of the water consumption data into one single hardware devices, and then they to transfer these data to the integrated systems. So commissioning means how to install the coordinator for reliable data transmission and then data acquisition. So first of all, they find some location of coordinators. They use the electrical pole for the efficient installation of such kinds of coordinators. They try to find the water meter locations, and they fix the display unit for displaying water consumption at each at households, and then these data is transmitted to the coordinator like this. So they try to find some good position or good locations. This is the example of coordinator locations. In the electricity pole, they install such kinds of coordinator. These coordinator collects the water consumption data into one single devices, and these data transfers to the integrated system over wirelessly. So if we try to send the data reliably, we need to open space for reliable communications. So sometimes electrical pole is the very good location to install coordinator. And next time the workers are replaced with the water meters. These are some kinds of several houses. These are electrical meters. These are outside the display units for displaying water meters consumption. These are water meters installed underneath the ground. But sometimes households don't want to install like this, because sometimes they don't like this kinds of equipment. So there are some problem, and they try to change the existing water meters, like a mechanical water meter, into a new one, new electrical water meter like that. So water meters are installed underneath the ground, and the display unit on the outside display for checking the water consumption at every household. So they try to change it like that. So and then they trying to register display unit because these are regulations to meet the Korea regulations. So these blue circle indicates some coordinators locations, and they can check the every household's water usage curves and monitor the values like that. And then they analyze some water consumption data at every household. And another thing is the smart metering then have some other kinds of application like smartphone applications. These applications for the customer services, so they can make some three kinds of content services. For implementing this content service, they try to specify some requirement for water informations. So we have two last slides. So these are some example of applications for customer. Water consumptions last 3 days, statistics, water consumptions like that. And the another thing is, I'd like to know the water quality of water suppliers, so they can check the pH, turbidity, or residual chlorine in the real time. So, but there are so many problems in implementing Korea cases. So our success or failure in Korea experience, I'd like to hope to have a more stable technology to the Nepal small town cities. Thank you for listening.
Thank you, Professor Ang. We'll take the questions again in the end. Thank you very much for the brilliant presentation. I think it must have raised a lot of inquisitiveness and curiosity in Nepalese engineers and managers community here, because we're also suffering a lot from NRW losses and bad metering, and that's our problem, right? So as you mentioned, so now we move on. Now we move on to the third presentation of the day. That is by Mohan. He's here. He's from Smart Pani. Okay, he's an international advisor to the Smart Pani, and then he's also an co-founder of Smart Pani. So we must be having a real first-hand commercial drive into the whole rainwater thing that we've been talking from yesterday. So Tyler, the floor is yours for 15 minutes, and we'll give you an alarm in 2 minutes. When then it's 2 minutes. Sorry.
Check. This skips, right? Okay, there we go. Oops. Hello, everybody. My name's Tyler. I'm one of the co-founders and international advisor for Smart Pani. Before Smart Pani, I was a Fulbright scholar. I studied the economics of urban rainwater harvesting in Kathmandu. Smart Pani has an experience of about 250 installations, and during my 10 months of research, I visited about another 50 more and surveyed another 450 households. So this presentation is based on, I call it reimagining rainwater harvesting. When we think of rainwater harvesting, when I listen to what people talk about, you talk about it in silos. You talk about whether it's individual household or individual sites or traditional infrastructure, but there's never the linkage of it as a complete urban water management strategy. That discussion I've heard rarely in 10 years in Nepal. So I want to discuss Smart Pani's experience along with a couple of my co-authors and lay out a bit of a strategy, a way forward. So this is Kathmandu Valley. This is 1989. How many of you were born in 1989? Sure, plenty of you weren't even born. There was hardly anything in Kathmandu. This is Kathmandu Valley now. in 2016. Not now, 3 years ago, that could have changed a lot. We know how fast Kathmandu grows. It's one of the fastest growing cities in Asia. Oops, wrong one. Sorry. What's the result of that? The result of that is many things. No water, people in queue for water, stone taps drying up, less than 50% of the water demand is supplied by the municipality. I won't get into leakage figures, demand figures, but you hear demand figures as many as 400 million liters a day, and optimistic supply before leakage of 150 million. So it's significantly less than demand. In addition, there's limited to no wastewater treatment functionality. The only partially functional plant that we know of is Kuashori treatment plant. And, oops, wrong button. Sorry. Kuashori treatment plant. And that's the Pashupati right above Kuashori. And yet, we have this problem. Every monsoon, it's a nightmare. If you want to go drive through Jamal, or Pudli Sarak, or anywhere else, and we saw exactly what happened last week as well. So what is rainwater harvesting? From perspective, it's actually cost effective. A lot of people think it's not cost effective, but for 15% of users and people in Kathmandu, it's cost effective in the fact that it can pay back in less than 3 years, even 2 years. It's also a very cost-effective stormwater management strategy, which I will get into later. It reduces demand on deep bore wells. This is very important, and not just in Nepal, but all around the world, it's considered a key part of urban water management strategy, and this is even in the US. A lot of the cities in the US are moving towards this as well. So this presentation will divide into 3 sections. This is the individual institutional economics. Smart Pani, as I said, has installed more than 250 systems. So we understand what customer costs are. And there's a large part of the population that relies on water tanker purchases. Anybody in this room, how many of you buy water tankers? Don't lie, I know there's more than that. Just 1, 2, 3, more, 4, okay. Actually, year-round in Kathmandu, it's estimated to be as much as 15%. That means right now, during the monsoon, when the municipal supply is there, 15% of households are buying water trucks. In addition, this includes institutions and everything else. In our experience, households who buy water tankers, who replace just 6 months of the water with rainwater harvesting using their existing infrastructure, their economic return is 2 to 4 years. And 4 years is for old houses that require a lot of piping. Additionally, private schools are very common, they can pay it back in less than 2 years. 3-star hotels, which are very common and growing in Kathmandu, and a very, very large percent of them rely on water tankers, can pay back a rainwater harvesting system in less than 2 years. There are car showrooms, they also use a lot of water, they also pay back systems in less than 2 years. And even public schools, Smart Pani has installed multiple systems across public schools buy water tankers. And they can never have enough water for students. But even based on their limited purchasing habits, because they're going to buy less than the private school, they're going to buy less than the household in terms of meeting the demand, they would pay back the system in 2 years. Because there are a lot of public schools across Kathmandu Valley that rely only on water tankers. Why is this important? One is, if you look at this, these are some areas with they occupy huge water demand and huge land area, which means there's a significant amount of rain that falls on their premises, on their rooftops, on their roads, and it also means they're extremely extractive from taking water from the bore well. Did you know that the estimate in 2012, they were estimating that around 70 million liters a day was supplied by deep bore wells? I have significant doubts about that. The municipality alone supplies up to 40 million liters a day just from their deep bore wells. Water tankers, somewhere around 75 to 80% of water tanker sites are deep bore wells. And the water shortage gap is 250 million liters a day. It's potentially a lot higher, potentially over 150 million liters a day. So if you can get them to stop using this for 6 months a year, you've automatically reduced demand in half. And that's very important because people buying water tankers, all of these can pay back their system in 2 years, which means they have a financial incentive. People using bore wells, if their bore wells are deep, really deep bore wells, they can actually pay back their system in 5 years as long as their piping isn't too complicated. Because to run a deep bore well, you need a 15 horsepower pump and a lot of chemicals to make the filter work. Second is, these areas and a house to reduce wastewater generation. When it rains, did you know that on every single one of your house, the other day when it flooded, you generated 5,000 liters of water? And all of that went to the sewer. Now in a typical day you use 350 liters of water, of which 300 would go to the sewer. Now you imagine the burden on the wastewater treatment systems that are hardly functional because of that amount of wastewater generation. That's a lot of water. And last is increased shallow aquifer recharge. In a lot of systems, once you install a collection system with financial incentives to overflow rainwater recharge is not very expensive. We had one customer who they installed a recharge system covering their whole property. It reduced their flooding massively. Their whole property would flood, and their neighbor's well actually had water pop up in the middle of the monsoon for the first time in 10 years. Kathmandu has a very, I would say, robust shallow aquifer, and a lot of people say that it's drying up because people are over pumping it. It's drying up because it's being surface sealed. These are some numbers for you. If you remember that map I showed you right at the beginning of the presentation, that red area that keeps growing and growing and growing, on that, in a typical monsoon, 150 billion liters of rainfall. Now imagine 10% of that naturally would have recharged if nothing was there. Now if you take this and divide it by 365 days, that's 420 million liters a day. 10% of that is 42 million liters a day, and that's naturally would have recharged. Given rice paddies and other systems, a lot more would have recharged. In the monsoon, every single day, if you divide again over the monsoon, there are days it doesn't rain, there are days it rains more and less, every single day 600 million to 1 billion liters of rain fall on buildings and roads in Kathmandu Valley. Now during the last storm, this is 50 millimeters. I think I've heard that the last storm that flooded Kathmandu generated 150 millimeters in a day and a half, 2 days. In a 50 millimeter storm, which is becoming more common, I was having an argument with a colleague that those don't happen very often, and he was telling me it's happened 3 times in the past 3 years. 5.5 billion liters of rainfall. Yet, the amount of wastewater treatment systems planned, not built, are 400 million. I believe actually built are significantly less than 100 million. The planned upgrades of those systems will equal about 100 million, and if they build that wastewater treatment down by Kokana, it will get close to 400 million liters a day. Now, 5.5 billion liters during a heavy storm, 600 million liters minimum to 1 billion liters of just rainfall going into the treatment system. I was going to say one of my co-panelists, but there's other students here, wrote a paper many years ago saying Guishoy treatment system, this is like 2005, I think, 2007, even then was not functional during the monsoon just because it rained, because the rain and the stormwater would go in. Yes, it dilutes the pollutants, but it overflows. It leads to what's called a combined sewer overflow or a sewage system overflow. And those are very, very common. They're very common all over the world. Did you know, even in the US, New York City, they have 40 of those every single year. In Los Angeles, they have tons of them. Philadelphia, they have tons of them. So what my point is, rainwater harvesting is not just collection. Rainwater harvesting is what's part of a larger urban water management strategy called green infrastructure. It's a tool. It's the first tool in rainwater harvesting. In New York City, they have started mandating rainwater harvesting. There's a company that goes around and installs rainwater harvesting rooftop systems. There are other ones that install tanks in basements in New York City. Bioswales hold, retain, infiltrate, and recharge groundwater. Larger wetlands do the same thing if you have space. Infiltration areas and what is called permeable pavement. So when you have a parking lot that floods like this, if that pavement is permeable, that flood will go away a lot faster, and a lot of it can reach an aquifer. This park is amazing in my mind. This was built after the 2011 flood in Bangkok. This has infiltration basins and tanks underneath it to hold 1 million liters of rain. So it's infrastructure like this that encompasses green infrastructure. Now some benefits and some case studies about green infrastructure. Philadelphia in the US, green infrastructure and rainwater harvesting are not some old-fashioned technologies. They're actually modern. In Philadelphia, the cost of implementing green infrastructure versus conventional gray, which are sewage treatment plant, upgraded sewage treatment plants, larger pipelines, was 1/4 of the cost. That means installing it gives you a 4-time return on investment versus cost saves. In New York City, they're saving $1.5 billion over the next 20 years. And this is older data, so it's probably the next 15 years now. There was another study of site-wise green infrastructure systems, whether it's collection, permeable pavement, all across, done by the American Society of Landscape Architects. that showed that 75% of them reduced the operational cost for that site, not the whole municipality, just that site, by installing them. And there's potential, we're talking about climate change and climate resilience as well, there's potential to eliminate the increased combined sewer overflow events in Toledo, Ohio. Green infrastructure has the potential, rainwater harvesting actually, not green infrastructure itself, the rainwater harvesting as a strategy in individual buildings has the potential to eliminate the increased CSO events in the city and only requires 800 liters of storage per building. And it's not like it doesn't rain there. It rains about a meter a year there, so it's not too far behind Kathmandu. Another study showed that in addition to all those benefits across California, as a source of water supply and the benefits, it was cheaper than desalination, new pipelines, every other single source of providing potential potable water to cities like Los Angeles. So, again, not modern. But what does Kathmandu have? I've heard about this a lot here, and I've heard about it in the past. Kathmandu should restore its traditional ponds. Its traditional ponds harvest rainwater. But yes, Kathmandu should. But Kathmandu needs to stop thinking about these ponds in isolation, like it's good to go to UNESCO or UN Habitat or somebody else and just get funding to restore ponds. Because if you look at how this is one of my co-authors' diagram of Living Mold, and she wrote this. This functions, the water supply goes, rainwater is harvested, restored, gray water even goes into these ponds, gets treated, held, retained. This is a century-old form of green infrastructure that already exists in Kathmandu. There are 200 plus ponds. It was 233 I saw in the recent Kathmandu Valley Board study. 40 are gone. There are a lot more encroached upon. But Kathmandu already has this. And it should be considered not as a let's preserve historical infrastructure, but as part of a larger strategy. So, based on Smart Pani's experience, I heard yesterday, how can you incentivize people to uptake rainwater? One is, even people where rainwater harvesting pays back in 2 years, they're still reluctant to invest. I've met some top businessmen and told them their system will pay back in 1.5 years. They're reluctant to invest. 1.5 years. But even if you're not completely tanker reliant, there's another 15% of the population that buys tankers during June, April, May, March. It rains 45,000. Last year it rained 90,000 liters on the average household's roof during that time. That's 6 to 7 normal tankers saved just in that time period. Those systems pay back in 5 years. So my recommendation is replicating what was done in solar. About 4 years ago, a bunch of banks introduced subsidized solar through the government because of the secondary benefits of solar power. Reduced pollution, reduced pressure on the grid. This is the same thing. You're reducing pollution, you're reducing the amount of wastewater generated, and you're augmenting the supply source. So introduce something like that through banks. That will help stimulate and allow private sector access. If instead you can have a system that you pay back over 3 years, you can even extend it to 5 years so that the maintenance problem is guaranteed. Like Chennai, as we heard yesterday, Chennai's systems don't function because they're not maintained. But if you integrate that into the plan, that's one. Second is stormwater generation fees. This is important. This is happening all over the world. If you're a large site, you generate a lot of rainwater. That is expensive to treat. So put some fee or incentive for these sites to trap their rainwater, use their rainwater. As I showed in a previous slide, a lot of these sites already have financial incentive to do it. So if you put a fee, it increases the financial incentive. It will save the government money and go over. Treat shallow wells as assets. 15% of the population relies on shallow wells. There's shallow wells all over Kathmandu Valley. Half of them are dead. Put them in as part of this infrastructure. Recharge some of the dead wells. It will help manage the urban pores thing, because the aquifer is only a few meters deep. The shallow aquifer is not very deep. It isn't that hard to recharge. And last, as I said, Kathmandu has a beautiful piece of what is considered green infrastructure, a modern strategy that's existed for centuries. So instead of treating that as something historical to preserve, try combining it with these big wastewater treatment projects and realize that how much benefit restoring that as part of the integrated strategy will actually save the rest of the efforts. It's a lot. Thank you.
Thank you, Mr. Tyler. That was also a very brilliant and eye-opening presentation for most of us, like how we can use our infrastructure in a very wise manner in our homes and how we pick back the economics part of it. Now moving on, now we have got the fourth presentation of the day. That's called Rainwater Harvesting, a key step of whole of water cycle management in urban areas. The paper has been jointly written by Navraj Khatewada, Anish Kimire, Vijay Thapa, Ekisha Sharma, Sangeet Nepali, but we have Vijay Thapa ji to present here today. So we give you 15 minutes again. Again, the same rule applies. You'll have a notified when it's 2 minutes remaining. Thank you.
Hello, good afternoon. I am Vijay Thapa, PhD student at Kathmandu University. And the topic of my presentation is rainwater harvesting. So it's a key step of whole of water cycle management for urban areas. And now talking about first, let me start with the paradigm. We need my first suggestion will be to change the paradigm. So my dress up is sort of shifting the paradigm. I'm not suited up. So it's the first thing we need to be careful is that the interests and the positivity among the people who are here, the stakeholders of water, wastewater, rainwater harvesting should be there always. So which we found in 2 days of this conference. And the second one is whole of water cycle. It's a strategy, actually. It's a strategy. It's a concept that says that water, no matter what the form the water is in, but we should treat that as a source of water. It might be in the form of wastewater, it might be in the form of stormwater, it might be in the form of beer, coke, whatever, but that is also water. So basically there are three sources that we can identify. One is the groundwater, the one is surface water, and then the second one is rainfall, stormwater, and the third one is used water. So using that as per the requirement, so that we can maintain the demand of the water. So this is the circular model of whole of water cycle. So we have this water source here. This is the snow, the water that will be. This is the rainwater harvesting sort of thing done here. This is the wastewater treatment plant. We are the consumer. The consumer are here. This is the irrigation, agricultural land, and this is the industry. So what we can do is this source will be used by the consumer. And then the rainwater could be harvested. This can be used for agriculture. This can be used for industries. This can be used by the consumer, and then the wastewater will be generated. The wastewater can be recycled to agriculture, or it can be used. It can be recycled to industrial use also. So that way we won't be depending on the clean water that is being supplied by the government. The next one is the next term is emerging hydrology. So basically, like for now, what we have been doing is when we are designing a sewer network, or when we are designing civil infrastructure, we consider the normal hydrology, the rainfall, the runoff only. So this is the consequence of that thing. So emerging hydrology, it's another concept where we don't treat the runoff as the only source of the water that will go to the drain. So we have to consider the base flow, the contribution from groundwater, and the sealing, as Tyler already mentioned. So this is one of the impact of that thing only. So there are more images. This is so we need to consider the emerging hydrology. We should not be limited to the data that we obtain by the calculation. We should do some simulations also. So when the ceiling increases, what will be the consequences at the end of the day? And here is another term, water sensitive urban design. Some people call it least impact development. Some people call it sustainable urban development. We call it water sensitive urban design. So it's another concept where we considered that the stormwater, that the runoff that goes that comes out of house or from the sealed area, that can be infiltrated. So this reduces the stormwater flow. It is very effective in reducing the flash floods. So this has been extensively used in Israel and then in Australia. here is another diagram. So it's the rainfall will come and the runoff will go to the drainage, and then we have some detention basin or a wetland which will absorb the water coming. So it avoids the water to directly go into the urban stream or to the drainage. So the runoff, the flood incidents will be reduced. So I have taken a small example. So let's say there is a house of 1000 square feet with a family members of 5, and then so if we do rainwater harvesting, it's a very simple calculation. I did it using year data. So we found that the total rainwater harvested, that could be in the range of 90 cubic meter, and then the demand is so the total rainfall that will be avoided to going to the sewer will be like 87 cubic meter. So it's a huge quantity that we will that will be very helpful in reducing the urban flood. And talking about the financial thing, so if Tyler, he knows more than me, but yeah, I have worked with him for like 9 months, so I can say that the payback period is very good if we consider this rainwater harvesting as an option at individual household also. Average rainfall in Kathmandu is like 1500 mm per year, and so 90% of the rainfall occurs in 3 months. So let's say that the average will be around 15 millimeters per day. Now consider the last incident of July 12, where the rainfall was 143. The recorded rainfall at Lele was 153. So in that case, per hour the rainfall was 30 millimeters. Now consider the area of 1 square kilometer. More than 7.5 cubic meters per second of flow will be generated by this rainfall only. So without considering like urban water sensitive urban design or groundwater infiltration for this storm water, the problem that we have faced this year will continue next year. The problem that we faced in 2074, where a child was drawn in the drain, the incident will repeat again. The incident of this Hanumante river will continue next year too. So what I suggest is there is this 4R principle in solid waste, so we need to use this in rainwater water management also, urban water management also. And rainwater harvesting and wastewater are the most I would again repeat, the most reliable source of water in terms of quality, in terms of quantity, because when you are consuming the water, you will definitely generate the wastewater. So if we consume like one liter per day, then let's say 70% is coming as a wastewater. That means we are getting 1.8 liters for every 1 liter that we get from the government. We should treat that way. And wastewater that can be used, that can be recycled, grey water can be reused, as shown in the diagram before. We can use this for flushing purposes also, and this reduces the water stress, the excess water, the urban flood, and the storm water that will be generated can be collected and can be used for street cleaning or something, some sort of purpose. So thank you. That's
Thank you, Vijayji. That was very good, both by presentation and by keeping up to time. And that was before time, rather. So I should really thank you for saving the time. Now we have from the desk. There are two more students there who will be presenting us. But from the desk, now we have got the last presentation here, and that's by a very young researcher like Sujata Koirala. She is doing her master's in Center for Environmental Development Studies in Trivandrum University, and she has a presentation today to us. So please, the floor is yours for 15 minutes.
Good afternoon, everyone. My name is Sujata Koirala, and today I'll be presenting on the topic Water Poverty Index of Chamunda Bindasaini Municipality, the Lake District. Basically, this research is about what are the factors that actually determines the water poverty of a place. So let me continue with my presentation. So this is my presentation outline: introduction, objectives, study area, materials and methods, result, findings and recommendation. So water poverty in Nepal is one of the emerging challenges to the local government as well as the country. An area can be water poor or water rich not only on the basis of availability of water resources, but also by considering many factors such as accessibility, capacity, use and environmental factors. Water Poverty Index is a simple, open and transparent tool which was developed by Sullivan, which helps the politicians and decision makers for making policies and allocating the budgets. WPI helps to express an interdisciplinary measures which link households' welfare with water availability. The general objective of my study is to calculate the water poverty index of selected municipality. For this, specific objectives are to identify the different types of water sources, to measure the stress and scarcity at selected watershed using the water poverty index. So this is my study area. Chamunda Bindrasaini basically lies in the dialect district of Far Western Development Region, and it is located in province Namasik and is surrounded by Bhairavi, Thatikat, Artbis Rural Municipality, Dulu Municipality and Acham District. The total area is 90 square kilometer and has total of 9 wards. The elevation ranges from 600 meter to 1770 meter. For this, the field visit was done from January 15 to 30 in 2019. 24 indicators for 5 components, that is resource, use, capacity, access and environment, were identified using different literature as well as primary study. For the resource component, the annual rainfall, annual crop water requirement, current runoff, daily water requirement, sufficient perennial runoff, perennial benefit factor was taken. For the access component, household that depend on distant water source, household that depend on pipe water source, time taken to fetch the water and maximum time taken to fetch the water in a whole ward, and total arable land were taken. Similarly, for the capacity, the literacy and the number of household with economic activities were taken. For the use component, the assumed minimum water, optimum minimum water, as well as the household with agricultural land with livestock, as well as daily water requirement was taken. For the environment factor, the water quality index were taken. For the another factor, the vegetation coverage were taken. Water poverty index is basically calculated by using this simple formula. For primary data, total number of 365 households surveyed from the 4,532 households with 5 FGDs and 2 KIA, as well as 12 physical and chemical parameters with weighted average method were taken for water quality index, and DVI was calculated using Landsat image. So basically, we have to score the map on the basis of 0 to 100, but there cannot be a perfect 100 score or the least 0 score. So according to Bonan et al., we classify the water poverty on the basis of these ranking. So these are the formulas which are required to measure each component. So basically, this is my result of water poverty index of Chamunda Bindrasaini. So you can see there are total number of 3 municipalities with medium range of water poverty, and the remaining are of medium high. The water poverty ranged from 49.62 to 41.33. And this is a pentagram which shows which component is more dominant than the others. You can see the use is only 4.37 because the people over Chamunda Bindrasaini do not use the water properly, as well as there are many conflicts considering the uses of water quality. So the use component is very weak, but the environment component is very high because the vegetation as well as the water quality was very good in that area. So this is the water poverty map of that area. You can see total number of medium and medium high result. So for the recommendation, WPI can be improved by updating its indicators and going for holistic approach by utilizing qualitative and quantitative data in an advanced way. The data unavailability can affect the WPI of the area, so we need to have the proper set of data because it's all about the numbers in this research, so we need to have the proper data. WPI can be used to monitor progress of that area, and necessary interventions can be taken to improve the water poverty index of that area. Drying of springs has also affected the WPI of that area, which is directly related to the rainfall. So we need to consider about the rejuvenation and all the other stuff to improve the spring area of reliability of piped water sources should also be maintained because Dailek is very rural place and the pipe sources are not regularly maintained. Even the water coming from the spring resources are not reliably coming, and there are many conflicts going on that area, so we need to check on that. And variability in rainfall increases the vulnerability towards water sources, so climate resilient activities should be promoted. So I would like to acknowledge all of them. Here are my references. Thank you.
Thank you. That is also before time and very well presented. A new methodology for calculating the poverty index, and that is a new concept in the whole seminar. Quite different from others. So congratulations for that. Now I think you must be, the audience is dying for the questions, but we have two very young students who want to present here, and we want to give the floor to them. So they are like they're both from Korea, and one is Mr. I don't miss In Yong Choi and Jin Kuk. Yeah. Can I invite both of you, please? Are very young students from Korea, and both of you can take your turns and how you want to present. So the whole team wants to introduce themselves. That's much better. So I don't know how they can do that, but is someone can facilitate? Will they speak English? Yeah. Okay.
Sapai janalai. Namaste.
Oh, I thought English. Then they speak Nepali.
हामी स्वयं सेवाको लागि दक्षिण कोरियाबाट आएको छौँ अनि हाम्रो युनिभर्सिटीको नाम इन्टरनेसनल युनिभर्सिटी हो अनि हामी हिजो बेनीबाट भर्खर आएको छौँ त्यसो भए त्यो प्र्याक्टिसको समय अलिकति थोरै मात्र छ त हामी आज त्यो काफी पढ्ने हो हुन्छ हुन्छ अनि यो कन्फरेन्समा सरहरू हुनु पाएकोमा धेरै खुसी लाग्यो धन्यवाद अनि मेरो नेपाली नाम वर्षा गुरुङ हो अनि म INU International Development and Cooperation with Rainwater Harvesting in Beni को बारेमा बोल्छु This is contents of our presentation. I'm going to talk about a purpose of our volunteering group. The purpose is INU International Development Cooperation recognize, empathize with, and cooperate to solve the problems of people's lives around the world. And we want to help build a common good in world society. And we want to help to build a common good in world society. Our direction is sustainable development cooperation, and main activities are improvement of education environment, providing various educational contents, and exchanging and cooperating between universities. let me introduce you to our previous activities. We volunteered 3 times at Vientiane Elementary Schools in Laos with the students of Laos National University during every vacation. We built new buildings and provided various educational contents. These are the picture of improvement of educational environment that we did in Laos. During the first period, the basic construction was carried out to build the classroom. In the second period, the surrounding construction was carried out. In the last period, the classroom was completed. For the provision of various educational contents, these pictures are our volunteering in Laos with Laos National University students. From now on, we will volunteer not only Laos, but Nepal with the same goal. We are expected to visit 3 times. Let me tell you why we decided to work in Nepal. As you know, Nepal is a mountainous country, so it's hard to storage the rainwater for living. And especially the Beni is located in a basin surrounded by mountains, so lowland areas, water treatment facilities, drinking water, sanitation, and water quality management is urgent. And high mountain area lack water all the time because it is difficult to distribute water to the top of mountains. To solve these problems, at the lowland area, we are going to use smart technology to manage the water quality. And at the high mountain area, we are going to use rainwater harvesting system to supply living water. Our INU IDC contents consist of improving education environment of schools and providing various educational contents. To be more specific about the first one, the purpose is providing living water by using rainwater. These are 3 steps. The first step is what we did in these activities. Improving classroom maintenance, and step 2 is setting rainwater harvesting system up during next winter break, and step 3 is reinforcement of the system and education about management. For this activity, our group consists of students of international universities and Tribhuvan University. For sustainable development of rain harvesting system, the Tribhuvan students whose major is related in this project cooperated with us. In INU, students who have various majors gather to provide diverse education. Thank you. About 쿠쿠 우아거 네팔리나 쿠쿠호 아니 쿠클레 번누.
This volunteer activity period is from July 19 to 30, and we visit Bernat Basic School in Beni for about 65 students and 6 teachers from kindergarten to 5th grade. Our volunteer students made up of 7 students from International University and 3 students master degree from Tribhuvan University, and the content is same as before. And for improving education environment of school, we are doing repairing roofs for preventing the leak of the rainwater, and developing a classroom for safety and flattening the floors in classroom and supplying teaching aid. And for providing various educational content, we had a class health and hygiene for raising awareness of hygiene and making it part of life. And we had a science experience subject for increasing the curiosity and causing interest in science, and art and sports subject for promoting creativity and developing physical and mental health. This picture our activities in health hygiene subject. We're doing washing hand and brushing teeth and garbage separation discharge and making mosquito repellent planes and cause of Nepal earthquakes and cold crabs and in the classroom too. There are too many students who lost their brother because of mountain disaster. So we planning to give them same education as Bernard School. Actually, my country, South Korea, had many hard times right after the war. At that time, we received a lot of help from other country with finance and education. So we was able to grow based on their help. We are happy to share the help that we have received. So we believe that we will grow up together and become brothers. We are very happy to be with Bernard School, and I'm sure that they were too. When I saw their eyes and found their smile, I felt I'm doing the right thing. So I hope one day, if the day comes, the day children will be like me, I hope they bring us to their mind and they will do the same thing. To make a clean water, the technology is enough for that. But to be a pure person, we need a love. And I wish our activity can be a lot of the love. I came to teach students, but I learn more from them. And I came to give love, but I got more love from you. धेरै धन्यवाद नेपाल।
ल वर्षाजी र कुकुजीलाई पनि धेरै धन्यवाद। तपाईहरुले हामीलाई यति राम्रो काम पनि गर्नुभयो, यति राम्रो कामबारे हामीलाई बताउनु पनि भयो। Thank you very much. Please we'll do the sessions now. Thank you. No, if there will be more we'll take the questions later on. Please be seated. Yeah, thank you. So now I think we've got very wonderful presentations here. 1, 2, 3, 4, 5 presentations plus very wonderful work that was done by our students from Korea who came here all the way to Nepal, to Beni, to a very difficult area, and did their voluntary work. So for this now we open the floor. Our questions are saying you can put it in Nepali, you can put it in English, you can put it in bilingual language. Then we can translate if this is required. So questions छ भने चाहिँ please यसलाई lively बनाऊ, questions गरौँ. Quite cross sections को paper आछ हैन. Ganesh sir, you have anything to start? Just like that. Or you please
gentleman who on smart
Professor Hong, yeah.
I was just wondering, I also do have a smart meter, and you were talking that the display has to come up. That has to be fitted with the meter, and who's going to do that? Yeah, the water company or the house owner itself?
Right now, it is not easy to apply the smart metering technique in Nepal, but I realized from visiting 3 times in Nepal, Nepal communication network is always reliable. So in the step-by-step based on the step-by-step analysis, we can implement some simple networking system to go forward the smart metering, like something water quality measurement by low power, by the something kind of Zigbee or something like simple communication technology, and then we can extend some smart metering technology, more advanced systems like that.
No, I'm just confused that you have a meter down in the ground, ground.
Yeah.
And you have also a display unit. So these are going to be two different things for the same purpose.
Install the water meter underneath, and then this water meter can transmit the data to the outside water meters.
Display. Okay.
Yeah,
So
two
two
things.
okay.
Yeah.
Thank you.
More questions, sir? Other? Yeah, Uddhav sir.
Myself, Uddhav Khanka from Tribhuvan University. It's just a query, so it may be pertinent to the professor from the Professor Hong, and related to the Tyler also. Whatever we discuss here about the meter, so you monitor only how much amount water they consume, or you also monitor how much they discharge the used water. Okay, so do you have any that dual metering system or single meter system? So in case of Nepal, as Tyler mentioned here, this is a economic tool. He mentioned in many schools and most of the hotels, they have the space and their return period is very short. Even being so, people are reluctant. So if we impose that, the imposed word is not good, if we encourage them to have our government to have the double meter system, they have to pay for the how much used water they discharge, so it may help. So it hasn't come to the discourse. So this is my queries. Thank you so much.
Professor Hong, please.
So yeah, I just talk about some measurement of consumption at water meters, but more bigger than water meters are installed in the water pipe systems. So if we try to complete water metering system, we can measure every water meters, because we trying to estimate how much water is consumed per hour, per daily, or per monthly basis, and then water supplier can handle how much water supply to some institution or some other hotels or some households. So there are so many measuring systems installed, and then they can integrate it into the single integrated system to estimate the water supply. So this is the very fundamental steps to measuring the water consumption at every household.
Mr. Tyler, I think you want to respond something to that?
I think more. I mean, the wastewater discharge would be important, but I think also with the storm, it becomes bigger land areas, and it would be more about making sure they have a good system, because I think it would be very hard to determine how much water they drain out. But as the system modernizes, potentially in the future, you could put discharge meters and implement something like that.
Again, comes back to the floor, please. We've got quite ample time here. The presenters were very gentle and very disciplined, stuck to the time. So we've got a lot of time left for us to interact. So should we have more questions? None? Lol, Professor? Yeah, of course, why not? Everybody is an equal participant. Even
this is pretty awkward. I am session coordinator. I have a question, but it gets more awkward because I have a question regarding Smart Pani, but maybe I am asking to a chair itself. That's why it is awkward. If I'm right, there is a environmental pollution tax fund in our government structure somewhere that because of the environment tax, we're making that environment tax fund, and then probably it is getting frozen, means it freezes every year because we don't have we cannot use, we could not use that fund. But I wanted to know about whether there has been some advocacy or there has been some processes to bring to subsidize the companies like Smart Pani as a kind of a environmental resilience, means to promote the environmental resilience. I'm asking you as the former finance secretary. Thank you.
But I don't like Tyler whether you are receiving any of that sort of support. No, not yet. No, not yet. So I don't think there is any environmental tax as such. There is a newly introduced system by Ministry of Forest as payment for ecosystems, PES, payment for ecosystem services. So that is that's not exactly in the act, but there was a lot of resentment on paying that. Because they were charging that to protect the watersheds and this. But so exactly saying that the payment for ecosystem services is being introduced by Ministry of Forestry and Environment, but they use it for, I don't know where it goes exactly. That is not a good tracking of that. The intention is to try and protect the watersheds and watersheds rather than protect the by default, because you protect the watershed means you protect the forest, means you also protect the water source. But other than that, there is not a system I know of that will really subsidize directly to companies like Tyler's who are working for Smart Pani. But then the question is, what is subsidizing some company? Like the question, if the government is undertaking a rainwater harvesting program all over Nepal, is doing a water supply and sanitation program all over Nepal, they all come from different tax money. So in fact the government is spending quite substantial amount of money in water sanitation services and irrigation and other electricity services. So it's one of the most like sector where the government puts in the biggest money, isn't it? Like even now it's 460 Arab, 46 Arab, what is that, 460 billion rupees, 460 million rupees. So it's a quite substantial amount of money, and that's the government is putting in, but maybe not really direct to pollution tax. The percentage tax is later, but there is some tax, okay, also like you said, for Bagmati rehabilitation. So the government was implied once imposed a taxation of about 0.5% in all land registration to be done that, so they could fund Bagmati. But the Ministry of Finance, whatever they do is they just put the money into a central treasury, but nevertheless the money is accounted. The money is accounted. Anytime anyone can go and look for the funds where they were spent. But then, yes, Bagmati also they're spending, but now they are saying that the government is saying that because of the advocacy, and then they're saying that no, we are giving money for Bagmati area rejuvenation, so the money is being spent there. But as of this, I must say that there is no scheme as such to sort of support companies like Smart Pani. Although there have been programs to support NGOs to go out and to subsidize, or village development committees, communities, and other agencies, even through your DWSSM, to support the communities to get their water sanitation, even rainwater harvesting programs, watershed management programs. All those things are going on. Jack, you want to say something?
Just to, I won't say clarify, but elaborate. What I was saying is, यो अर्को माइक छ Hello, this one's better, right? It's not about, I would say, subsidizing companies directly. Actually, the reason I brought up the solar loan example is One, when you're using the alternatives, which is a deep bore well, or you're discharging excess rainwater into the pipes, or you're buying water tankers, they're all externalities of that. They cost money. So with a solar loan scheme, all it did was make the solar system, like imagine this phone as a solar or as a rainwater harvesting system. It made this collateral. I can go to a bank and get a loan for a rainwater harvesting system, but they ask you to put your house up as collateral. It made the system itself collateral, and then it lowered the interest rates because of the secondary societal benefits. And that allows not just one company, I saw Narendra in here as well, I've seen others, there are other companies as well. It allows a competitive market to offer services and convince a larger percentage of households, because if 30% of Kathmandu is buying tankers at least part of the year, they'll pay back. And if they can finance it over 5 years, instead of it coming out as 50,000 or 80,000 rupees, it's a monthly payment of a couple thousand. So the subsidy would actually be an investment in avoided costs of wastewater treatment drainage, for example, like the gigantic one they're putting through Patan Durbar Square, reducing the cost of things like those and the failure of things like those, while creating a competitive market for more companies to address these issues.
Thank you. That's an innovative idea that could done that if you could fund that without collaterals, or the banks could do it out of their funds. So it's more of a marketing from the sector, marketing to the banks, because the banks will only lend when they know that this is going to be recovered, that there's got some money that's coming up. So it's the matter of convincing that how we can go convince and do this. But there are opportunities like that we can approach the government, we can approach the ministry, we can have the Ministry of Finance and NRB, Nepal Rashtra Bank. They can issue a directive, because Nepal Rashtra Bank can issue directives about what the banks should spend on. So this could be eligible for environmental financing or the CSR financing, or not even CSR financing. It's like from what Tyler is saying, is you can pay back very easily in 2 to 4 years. So it's more of a commercial, not exactly in commercial rates, but most likely subsidized rates maybe. No. Yeah. So but that's what law. So but solar there is, because solar they are getting this because of AEPC, mostly because AEPC is a program that's funded jointly by USAID, but there are many donors funding that. So if there is a donor community who is trying to fund this, that can also be done. Like for solar commercial funding also, now ADB is providing a viability gap funding. So now that is beyond 7 rupees 30 paisa is what government has decided, but beyond that, whatever is the money, the difference, the ADB funds can be used for certain time to promote solar. So solar is being funded by two things, like one is AEPC but we must be able to set up some fund. That's a good idea, that we could all work together to establish a fund and a sort of a coffer where things can be drawn up from. So now, yes, please, more questions to our students or to panelists or paper presenters, anybody? Mr. You want to ask something? You enjoyed it so much. Okay, Purushottam, sir, you want to say something about environmental tax? No, there was a question about environmental tax. You are very knowledgeable, no? Sure.
Yeah, this is very good opportunity. As I introduce some our collaboration from Korea and Nepal. At that time, we trying to incorporate our smarter technology to in Nepal, especially from the Beni city, because I discussed with the Ministry of the Water Supply and Sanitation. At that time, so they decide it is better to take out one test bed. There's the Beni city. So from the 3 years, we trying to find out what data can be collect through something. Also, today I'm very enjoyed with the student, because this is we need to transfer our technology to Beni City, as well as we need to make a better collaboration, even the cultural situation through the exchange for the students, as well as for their ability or their cultural exchange something. So that's why we enjoy so much. Anyhow, we really wanted to continue that kind of collaboration between two countries. So please give the big hand for students for that. Thank you. We enjoy. Okay.
कहाँ छ यहाँ? John Das, your presentation from John Das ji? John Das from CDS? What do you want to present like, please? You can come forward. So please. No, we can't give you much time because you are not listed there, but if you can do it in 5 or 7 minutes, we'll be encouraged to do that because quite some time left. So you can use this microphone. John, please can you also introduce yourself a little bit?
Okay.
You start, okay.
Namaste, I'm John Das from Central Department of Environmental Science. It's a great honor and privilege for me to present my paper entitled Scope and Cost Benefit Analysis of Rainwater Harvesting in the schools of Livelihood district. So yesterday we have a poster competitions, and I'm very glad that the study could achieve the first positions, and I'll be sharing the glimpse of my study over here as the time is a limit. I want to give my thanks to my supervisor, Assistant Professor Dr. Man Kumar Dhamala.
Can somebody help that with the pointer?
Okay, that's fine. So, nodding into the introduction, as we all know what the rainwater harvesting is. However, I just wanted to take you to why it is importantly necessary for Kathmandu Valley, because the population is increasing every year, and the population pressure is one factor. Similarly, as we look at the groundwater situation, 60% of water demand is currently fulfilled by groundwater. And according to a study by Gautam and Prajapati in 2014, the groundwater table is decreasing with the standard deviation range of 0.28 to 3.76 meter per year. Similarly, the water supply by Kathmandu Upateka Khanipani Limited is only about 30%, and it's even worse in dry seasons. Sorry. So I just wanted to take you to why I choose to do the study in this topic. First of all, my school also had the same issues where I studied. They used to rely heavily on privately supplied drinking water. For that very reason, I just wanted to check whether rainwater harvesting is a good solution for water scarcities. So I keep my objective as to study the rainfall availability, water demand, and rainwater harvesting potential of school. And at the same time, I also set an objective to determine the cost benefit analysis of rainwater harvesting in terms of payback period. So I choose 8 schools in Livelihood metropolitan cities, and questionnaire survey and other data were used. So for annual rainfall availability, I use the formula given by Gould and Nissan 1999, where rainwater harvesting potential is calculated by multiplying the mean annual rainfall into rooftop catchment area into coefficient of runoff. Similarly, the water demand were surveyed by questionnaire surveys, and to have a payback period in a year, I divided the installation cost of rainwater harvesting by the save in water bill after the installation of rainwater harvesting. So the results were the average annual rainfall of 23 years average data show that it's 1609.85 mm per year, which is very good for rainwater harvesting. However, as mentioned previously by many speakers, it is concentrated in the 4 months of monsoon. For that very reason, the main issue over here is how to store it efficiently for the use in non-monsoon periods. Similarly, while talking about the rainwater availability, in theoretical term, we can have rainwater availability for about 80% of year. However, because of the lack of storage, so it's the availability in the surveyed school was 4.37 months, and it depends on the storage species. For example, Sramjit Kishore schools have the rainwater availability for 6 months, and other lag behind in these issues. So the increase in catchment area and storage volume will help to increase the rainwater availability for the extended time period. Similarly, while comparing about the harvesting potential with demand, as I already mentioned, so harvesting potential is 209.6 meter cube, and the average water demand is 265.08 meter cube. And you can see that almost most of the schools have a very good demand potential relations, and the major factor is the storage. I will be discussing it later on. So what we see is that theoretically we can have almost 80% water availability. However, because of the practicality related to storage systems, so it's only 36.41%. The proper harvesting and storage of rainwater will help schools to decrease the water bills, prevent the unsustainable groundwater use, recharge the depleting groundwater, and at the same time decrease the unavailability of water in non-monsoon periods. So while doing a cost-benefit analysis, I have a discussion with Tyler yesterday, and yes, almost if you just compare the cost of rainwater harvesting system only, the payback period is almost 2 years, and in more 4 years. However, as I also consider the storage system construction, because some of they have opt for 2 wells construction to store excess water, and at the same time they, when even after installation of rainwater harvesting, they increase the number of tanker, and they increase the number of PVC drum as well as stainless steels. For that very reason, their costs were higher during my questionnaire surveys. So it was as less as 2.7 years in YMBA schools and as high as 14.92 years in Saraswati school, because they have dug another wells so as to store more waters. And the schools paying high cost for privately supplied waters and having greater water storage space as the lowest payback period, and which is just opposite for another case. And similarly, the payback period can be even lowered for rainwater harvesting by development and installation of cost-efficient, technologically sound, and easily available storage system. So my conclusion was that rainwater harvesting is the best option to fulfill the water demand in the schools in Lalitpur district, facing acute water shortage and paying high price for privately supplied drinking water in terms of scope and payback period. So these are the differences. So I want to conclude with the final words. If you want to get respect from new generation, then please save water. Thank you all.
Thank you, John. That was a very good presentation. Maybe you'll have something good to hear, and that was very good also. So I think if there's no more questions, then we can actually think about closing this session. It has been a very wonderful session with all the paper presenters, keeping up to their time, making their subject matter very... Sabaiले thank you भन्नु है भने यता मैले हैन पछि टोकन ए तपाईले बोलाउनु. So taking up to the time, that has been a very wonderful session, and also by the content, there has been quite a big cross section of content in this session. I must say I'm really very happy to be chairing this session because of such eminent panelists, paper presenters, and these beautiful students who have come all the way from Incheon University, Barsaji, Kukuji, and her friends. Can we give them a very, very good hand, please? And that was very nice, and that was very, very, very kind of you to come and present here. And after that, this session, our paper presenters, they're all very brilliant. A wide cross section of issues that are covered. So I think we covered a lot about rainwater harvesting today, and beyond rainwater harvesting, about rainwater using, misusing, abusing, and not using, right? Everything of rainwater has been covered here, and I think we got to get towards going to this. So this is about rainwater harvesting. I think we should start thinking more beyond harvesting and about total management of rainwater, like Tyler said, like or other Arne said, or even integrating IT to it and try how to manage it more smartly, more efficiently, and getting more gains from that. So it has been a very wonderful session, and I must thank the organizers for giving me this opportunity. Thank you, all paper presenters. Thank you, everyone. Thank you, coordinator. And thank you for the very, very wonderful, beautiful audience who has been very disciplined and very, very participative. Thank you very much. So I hand over the microphone to Rajit ji, who can to take it further.
Thank you for nice presentations. The organizers have provided us the token of appreciation, including me. And the session chair is going to give the token of appreciation to Dungwoo Jung first.
Thank you. It is such a wonderful presentation. So, thank you very much.
Second one is Professor Sik Hong. Tyler McMahon. Tyler McMahon. PJ Thapa. Sujata Koirala. And Kun Yung Choi and Do Jin Gu.
Thank you very much. Very धन्यवाद. Thank you. Very thank you.
And as a token of appreciation for chair, I would like to call upon former Minister Ganesh Shah to give the token of appreciation to the chair.
Thank you, sir. That's very nice, huh? So it's like come everybody, I don't have another token of love coming for our moderator. Thank you. Please come. Dr. Choi, we have another photograph. Okay. Because we have time. 5 minutes, then I'll go for the. No. This way, come. Okay. Good. You know, okay, thank you. The photo, एक बार लिया, friend को दो. Token of the.
छैन होला सिधै होला
बोल्या? हाम्रो के नाम हो?
रजित ओझा.
ओझाजी.
डक्टर रजित ओझा. डक्टर रजित ओझा.
डाक्टर लोग तो महंगे काम होते हैं,
डक्टर साहब
Thank you very much for joining. We end the session. Thank you very much.
4:30 मा हाम्रो closing session. There will be a closing session at 4:30 in this hall. So we will be some making arrangement for the stage, and there will be outside tea. So you can have tea, water, what we call the toilet break nowadays. Yeah.